So thank you for everyone again to join us for this interesting session that Tim prepared for all of us about support materials from INTAMSYS. So yeah, we are doing this session from Germany. We will do a short introduction about ourselves. I think I see actually there's also, even it's quite late in the afternoon in Germany, we still see people joining from Germany. So thank you for that. Tim, maybe you can start to introduce yourself.
Yeah, so hi everyone, and good to see you, also to the US people that I'm usually not talking so much to. So welcome to the webinar, and thank you for taking the time today to listen to INTAMSYS and to know what we want to offer and what we have to help you with 3D printing. Yeah. My name is Tim Bostidlo. I'm Application and Technical Support Manager for the EMEA region, and I'm responsible for all technical topics in Europe. I'm since 7 years in 3D printing, and I joined INTAMSYS in February 2020 to make printing of high-performance parts and engineering plastics great again. Yeah.
Thanks, Tim. So just a few words about myself. I'm Hao Yang. I'm also based in Germany, Stuttgart. I'm more from a sales and operations side, so taking care of the EMEA team here. I joined INTAMSYS since 2019, now more than 4 years already. I think that's it. Maybe go to next page, Tim. Yeah. Just very short reminder, we will have time in the end of the webinar to answer your questions. So please feel free to ask any questions already during the webinar using this Q&A button at the bottom of the Zoom. Please do not use the chat, otherwise we will have difficulty to track your questions, eventually come back to you after the session. So please feel free anytime, raise your question, and we will pick up the question at the end of the webinar, try to answer as much as possible. Otherwise, we will get back to you after the webinar by our local team. Okay. So basically, what you can get from this webinar, or why we would like to do a webinar based on this topic, is actually we received a lot of questions and we had a lot of exchange in the past regarding the support materials. As a machine manufacturer, actually, it's quite obvious for us. We would like to provide a total solution, also including materials. And we also faced a lot of difficulty and challenges in finding the proper support materials for the main materials, especially for the engineering materials and also for the high temperature materials. So that's our motivation, and we actually did a lot of work in this area to develop our own materials. Tim will go more deeper into this topic later. Of course, we would like to also make sure that every materials matches well, and also not just the main materials, and also with our printers. So Tim, I would like to hand over this to you, and I think you prepared a lot of interesting content. So so you can start now.
Thank you very much, Hao. So let us have a closer look on how the presentation is structured. First of all, I will give you a quick introduction to INTAMSYS, who's INTAMSYS, where we are from, what are we doing, for the ones who are new to INTAMSYS. I will introduce the support topic, generally speak a little bit why supports are required, how supports are used, and what kind of support materials can be used, more from the category than specifically talking about it. And in the end of the presentation, I will look with you together into our printer portfolio, like what printers can we use from our portfolio to print our support materials. plus the specific support materials, which support material to combine with which build material, and the why and the what. So yeah, again, thank you for listening, and don't forget to ask your questions. Use the Q&A button, ask them within the presentation once you have something, and at the end we will go through. So let's start. INTAMSYS, for the ones who don't know, INTAMSYS, we are an FFF 3D printer manufacturer, and we are the leading manufacturer for peak 3D printers in the number of shipments, yeah, with our FUNMAT HT, the 410 and the 610 in all together. We are a fast-growing company. We have famous investors such as Sequoia Capital, but also Porsche Venture Capital, and many other investors that help us to let INTAMSYS grow and to grow our team. Yeah. One investment INTAMSYS is doing to the market is we started to build up a global sales and support network. We have local resellers, we have local offices in the US, in Europe and Germany, and we also have it we have our office in Shanghai and the second office in China, actually. Yeah. And with all of this, we try to get closer to our customer to help locally where demand is coming from. We want to be there for our customers. Yeah. Overall, we are focusing on industrial solutions. Yeah, so it starts all with desktop printers, whether the FUNMAT HT, but also the FUNMAT Pro 310, which are true desktop printers, but still very industrial, many metal parts, many machine parts, very heavy, rigid, and sturdy printers. Yeah. Then it goes to the FUNMAT Pro 410. This is the blue one on the picture, which is like an entry-level production printer, I would say. You know, up to the FUNMAT 610, which is like a 1.5 ton, really heavy, big industrial printer with high heated chamber for closely all materials of our portfolio, from PLA to ABS to PC to PEEK to Ultem. All of this goes very well on that printer. To develop these printers, we have many people in our high-tech team. We have around 50 people in R&D for slicer development, firmware development, mechanical engineering, electrical engineering, material development, process engineering, so printing process engineering, and so on and so on. And this is a very high number of R&D people, and we do this to bring fast the solutions to the market that are so demanded from our customers. Yeah. If we look a little bit into the history, INTAMSYS was founded or started in 2016. We launched our FUNMAT printer in 2017. We had the FUNMAT Pro, we had the FUNMAT HT a printer. We are still selling 6 years afterwards, which is still super good to print peak parts with a desktop printer. Yeah, even though it sometimes look not up to date, it prints very, very good. Yeah. In 2018, we released our FUNMAT Pro 410, and the next level of our printers, the entry production printer with water-cooled printhead, with dry chamber for the filaments, automatic leveling, run-out sensors, like a smart machine, really good for production. Yeah. In 2019, we started to establish our European office, but as well we launched the FUNMAT Pro 610, which we started to work with the first customer projects, which we installed in 2020. And this was also the reason why we in 2021 did another venture capital round. We had an investment from Porsche. We established our US office. So we really grow from year to year. And last but not least, end of last year, we announced our FUNMAT Pro 310, yeah, a new printer in the desktop segment, made for engineering plastics, can print all engineering plastics, ABS, ASA, PC, PA6, PA12, with carbon fiber, with glass fiber, all what you want, and this with a quality that is unreached in the desktop segment because of its 100 degree heated chamber. Yeah. And in the end, yeah, long talking, but what you see is we are a really growing company, and we try to make more products. And what you don't see in this is our material development, but this is also something we invest a lot of resources into it. And as how mentioned in the beginning, it's not only about printers. So we are a printer manufacturer. We have our printers from desktop to full industrial printers, but we have the strong belief that the printer is one part of the success in 3D printing. It's also about the materials, and it's also about the slicer. It's about the firmware, the software on the printer, and so on. And what we try is to deliver a total solution to you as a customer, to say, like, this is the printer. For this application, you should use this material, this support material. This is the slicer. This is the profile you go with. You slice your parts, and we call this click and print. Like you pick your parts, you orientate, and you choose the profile, and you go and print, and you have successful printed parts. And this is important because you do not only need a good machine to print good parts. You need a good material. You need a good printing process to have a really good part in the end as the outcome of your printer. Yeah. But today, I don't want to talk too much about INTAMSYS and the history. I really want to focus with you on supports. Yeah, why do we need supports, and what solutions are INTAMSYS offering? So first, let's have a look into the introduction of support structures. I guess most people know the working principle of FFF. Yeah, we build layers by layers from bottom to top. Yeah, and for geometries with an overhang higher than 45 degree, support materials are required. This depends a little bit on the material, and some people say, yes, but I can print overhangs of 50 or 60 degree, but 45 is a good number to start with. And the reason why this is happening is because we are placing layer on layer on layer, and if there's nothing at the previous layer, like there's an overhang or like a bridge, so-called bridging, then it would just place the support material in the air. Yeah. And then we would have a problem because our layer could not stick to something. You can see this very well here in the graphics. Let's say we would like to print our INTAMSYS logo, and we have some letters like the S or the M or the Y with overhang. So what you see here is the overhang. So let's say part of this is printed in the air, but the overhang is only 20-25 degrees. So there's no need to use a support material. But if we talk about the S or the M, we could clearly say we build up the layer, and then somewhere we need to make a bridging. And if we would have no support material here, the nozzle would try to apply the material, and afterwards it would fall down instead of sticking to something. And this would result in very bad parts, bad contact surface quality, and the risk is even a total fail of the print, including a damage on the printer. So this is something you really don't want to have. So support structures are demanded. The question is only, how can you make support structures better in the printing process in terms of removing them and printing them? So the option that definitely everyone knows who's into FFF and ever printed something is so-called self-support. Means you have your build material, you have one nozzle, and you print with the same nozzle your build material as a support material. Usually to make this possible to remove the supports, there's a certain gap between the support structure and the part. and you need a certain gap because otherwise you cannot break away the support structure, because you have a good adhesion from layer to layer, and if there's no gap, the support will be too strongly melted to the part. This would result in difficulties to remove. Even though you keep a gap, it's still a bit more difficult to remove because the adhesion from one material to the other, the same, is usually very high. If you print with self-support, you also have a high porosity at the bottom of your parts, or the support interface, the contact side, yeah, and also the lines will be more fragile because they are not squeezed into the previous layer. They are more like laying down somewhere half in the air. Yeah, the benefit of this is faster in printing, compared to using a dedicated support material. But definitely using a dedicated support material brings also certain benefits. And in my opinion, the benefits are definitely bigger than the downside of a little more printing time. So first of all, when we print with dedicated support materials, this is the same for all of our support materials. We print without a gap. Yeah, so the model material get directly printed, like one layer after the other layer, get directly printed on the support structure. This will help to get a very good surface quality. Still, it's easy to remove. And if you now think like, but Tim, you explained it will be difficult to remove without a gap, we can say this is related whether to the fact that it's a water soluble. So even if it sticks strong, we dissolve, then there's nothing left. Or it's a special formulated breakaway that has enough adhesion within printing, but low enough adhesion to remove it properly after printing. Yeah, and this is something you will see a bit later in this webinar. The real benefit is there is no gap. Yeah, and the no gap means very good surface quality of the part. And I would even say on some of our support materials, it's very difficult to see the difference between the top side and the bottom side of the part because it looks so good. This takes a bit more time of printing because the printer needs to change the nozzle. Yeah, this takes a bit more time. I would say roughly 10%, depending on the geometry of the part. But it's definitely worth to spend this time. As I already said, there are water solubles, there are breakaways, and that you get a little understanding how those structures get removed. We prepared a little more content for you. Actually, in this video, you will see our PA6 carbon fiber once combined with one of our support materials called SP3030 and once combined with PVA. Yeah, let's have a look. So actually, this video has a real time of around 30 minutes, and the water had a temperature of around 60 degrees. We originally made this video to show the faster dissolving rate of SP3030 compared to PVA, because here you can already see many of the structures get dissolved, where here you see some of the structures are removing, but still it's very dense from the support structure. And what I can tell you is the dissolve rate is much faster on SP3030, and it's also easier to clean up. If you would now like to do some manual cleaning, it's much easier. But I will talk later a bit more about the difference in the behavior of PVA and SP3030. Let's now have a look into breakaway support materials. Yeah? Most of our support materials are actually breakaway support materials because the development of water solubles is more difficult, or solubles is more difficult. And with breakaways, we see it's also a very fast removal time. So actually, you see the same part on the left side, printed with PA12 carbon fiber and our PA12 support material SP3050. and on the right side, PA12 carbon fiber with self-support. Yeah, so you see by the color, it's printed out of the same material than the part. I would say, let's have a look at the video. So it already starts with the raft. The raft is easier to remove when it gets to the part printed on the left side. And what you also can see on the left side, I just started to grab some of the structures and already removed the support material, including the support interface, so the top layer of the support structures. And you can see it's really, really easy to remove it. As soon as you find a section where you can get down with your plier, you can just lift it and peel it off. So on the left side, we are already at the outer ring of the support structure, and on the right side, we're still trying to remove the interface, break the structures a bit more, yeah. Because if there's too much structure remaining, you cannot peel it, and then the removal is much more difficult. Yeah, and what actually I really like is the effect, like the pattern you have on this belt pulley, that you can just remove this whole support structure circularly. So you just cut it, and then you pull it off in one circle, let's say, and you will see and you will recognize on the right side where we use the self support, it is much different. Yeah.
19. Yeah, this is how speaking. So yeah, we see that actually it's quite much faster when we use dedicated support materials. But how do you comment on the fact that actually using a self-support actually save time on the printing? So actually it has also its benefit, right?
Yeah, I mean, in the end, it's a bit a question of what do you want to achieve? Yeah, because sometimes you have parts where you could say, I don't care about the support surface. Yeah. Sometimes we have customers that say, I don't care about the labor time. If it's 1 minute 20, if it's 5 minutes, there's no big difference for us. Yeah. But what we can say is our belief is it takes a bit more in printing time, but it brings a much bigger value in the quality of the part. Yeah, so it's not only about the removal time and the printing time. In the end, the final result is what matters. Yeah, whether you are a service bureau or you need parts internally, if you have parts that look not good or partially not look good, it's always a topic that gets into discussion, like why is this side not looking so well? And as I said in the beginning, we have materials, and SP3050 and PA12 carbon fiber is one of them. Where the supported area looks closely the same than to the top layer. Let's say if you print a cube, it's very difficult to recognize the difference between bottom and top. And I would say it's not only about speed. It's in the end the quality. Yeah, and we all know we're talking about serial production. People want to do more with parts, and this is definitely the time where we start to say we need a more mature technology, and we need to have reliable parts with reliable quality. Yeah.
True.
Yeah, and you see how where we start to discuss the right video is still in the support removal, just finished. And for your reference, the right video is around 4 minutes 30, and the left video is around 1 minute 20. So I would say it's around three times faster than the dedicated support material compared to the self-support. But as I say, the bigger difference is the quality. Yeah, because if you are looking into the part afterwards, you would really see on the left side, yeah, it's closely impossible to see the lines of the printing process, yeah, and also in the overhang you really see a smooth surface, and you have a very low porosity in this. Yeah, this is very important if people touch parts or parts need to be cleaned or painted or whatever. Too high porosity is a problem because you cannot apply filler. You need to sand them a lot before, and so on. Yeah. So you can see this is the bottom side, and I think this is really a good quality level that you can achieve with it. If we compare the self-support here, we see the lines are they look like under extrusion effect, because you have no bottom layer, like no support interface where you squeeze your lines. They get half printed in the air, and therefore it's a little bit weak. And what can happen sometimes, because here it just look not that good, but it's all right, the part, let's say. But what I found on the first layer of the part, where it has had contact to the raft, I even ripped off some lines. Yeah, so I just peeled off the raft, and not too hard, but let's say to make it time effective. And then you can even damage those lines. And with the dedicated support material, you have an easier removability and more strength in the first layer or in the contact layer, and therefore the part quality is really noticeable better. Yeah. And this can be only achieved because of specific material formulations that allow us to print with zero gap between the support material and the main material. A question that we get sometimes: hey, should I use a breakaway? Should I use a soluble support? Actually, this is a question we can answer easily, because in most cases we only have a breakaway or a soluble material, that a support material that is compatible to the main material. Yeah, I will show this to you in the end. So in most cases you do not have this choice. But if you look into it, and let's say you are in a perfect world, you could still make your decision. First of all, a breakaway material is easy to remove. Therefore, it allows a very fast removability. It has a very good printability, and this is depends on the company and on the region. But it also allows easy disposal of the resin. Because sometimes, and especially with solubles compared to it, you use solvents or you have wastewater, even if it's a water soluble, and this is sometimes a big problem for some people. And I think a breakaway support, you just have some plastic waste, you put it to your plastic waste recycling, and you are good with it. Yeah. The downside of using on a breakaway support material is that it has still difficulties with very complex geometries, whether a part with a cavity, yeah, where you cannot access it, but also with very thin wall parts with small details, because once you need to start to peel it away, there can be still a risk to bend your part, to touch your part, and to break it when it's complex and fragile. Yeah, and as I say, it requires in the end accessible geometries. So a part with cavities is much more difficult to be printed and to be removed in the end. Yeah, and this is the main case where I would say you have a benefit from soluble support, because it is very easy to remove. You just put your parts in solvent or in water or in another chemistry solution, yeah, to dissolve it, yeah, and this makes it very versatile and accessible. But this sounds a bit like a dream world, because there are also downsides of it. First, dissolving takes more time. Sometimes you need something on a production line, you need a spare part, and then it can be about minutes and not about hours. And if you have a soluble support, you still need to wait 1, 2, 3, 4 hours, depending, or even more, depending on the part geometry. Yeah. With PVA, I already had parts that need 2 to 3 days to dissolve, and with very, very big amount of support structures. And this is something you do not have with a breakaway, because as long as you are able to remove it, you can remove it directly after printing and get your parts really sooner ready. Yeah. Speaking from our portfolio, I can also say the tendency is there that the soluble supports are more expensive than breakaways, or also the build materials. This depends a little bit, but at least speaking from our portfolio. Also, water solubles or solubles are more difficult to print, especially materials like PVA. They are not only horribly moisture sensitive, they are also very sticky. They like to stick around the nozzle. They have a very low softening point. They like to get stuck in nozzles. When it's hot outside, some printers get already troubled to print it, and so on and so on. And this makes it, for me, definitely more difficult to print. And in the end, as I already mentioned, a big downside for some people can be the disposal, because for the most regions, it's okay for water soluble to dispose it in the water until you do not have reached a certain limit of it. But in some countries, it's also more difficult. And when it comes to the fact that there's no water soluble, like acrylate-based material, it can be also the reason that it's not okay to dispose it to the water. And then you really need to think about, like, how can I dispose this special residue. Yeah. Let's now have a quick look into the printers that we offer that have a dual extrusion system, and then we go page by page through all of our support materials, including the main materials you can combine with them. So the first printer on the left side is the FUNMAT Pro 310. Yeah, it's our industrial desktop printer with IDEX dual extrusion system, and it's made for all engineering plastics, from ABS, ASA, PC, PA6, PA12, with fiber, without fiber. It's a very great printer for it. And actually, we released it last year on the Formnext, and we do start with shipment actually. So if you are interested into one, we start to stock it in the US, but also in the EMEA region. And we see it's a really good and reliable printer, and something that really brings additional values with its heated chamber and the capability of such a broad range of materials. The next printer is the FUNMAT Pro 410, our entry-level printer for production, entry production printer, I would say. We have actually customers in Europe that have multiple of those printers, and they print, for example, peak parts in the serial production. We see the Pro 410 is perfectly for fiber reinforced materials, but also for selected high performance materials, like a PPS or peak-based materials, AM200, PEC, and so on and so on. Our flagship is the FUNMAT Pro 610 HT. It has a 300-degree heated chamber. Yeah. With this 300-degree heated chamber, we have the ability to print all materials, starting with PLA, ABS, PC, PPS, PEEK, Ultim, and all materials you can imagine currently on the market. And with the 300-degree chamber, we have even more room for more materials if more new developed high performance plastics are coming to the market. Let's now have a look into our portfolio. So as I say in the beginning, we try to offer a total solution to our customers. So it starts with the materials, but also with the support materials and the printing profiles in the slicer. Because what does it help if you have a good combination, but you don't know how to print? You need to tune all settings, temperature, retract. You will spend hours. And what we want to achieve is you load and you print with those parts. What you also see is we have our so-called CAEP, or Customer Application Enabling Program. This is INTAMSYS third-party material program, where we certify selected materials that bring additional value to our portfolio, whether it's a special certification or for special applications like ESD from Kenya for electronic parts and fixtures in the electronic industry, or Victrix AM450, which has oil and gas certification, and other materials. So we are not someone who's adding thousands of materials and just say we have the biggest range. We want to do it on demand. We want to understand what customers want to print, what parts do they want to print, where do they need specific materials, and then we look with our partners together to get those into our CAEP. We start with PVA, our first support material that I would like to introduce to you detailed. PVA is a water-soluble support material. It's made for PA6 based materials, but it works also with PLA, with TPU, and some other materials. As I was saying in the beginning already, or in the presentation, PVA is not very easy to print. Yeah, it's very sensitive to high temperatures. So in a printer in a hot environment, it can get already more difficult to print. Due to the fact that it's water soluble, it's also very moisture sensitive. So the right drying, the right time, the right temperature, and drying PVA or other materials is very important to be successful in this combination. Yeah. On the right side, you see a part which is made out of PA666, so a nylon material, with PVA together. One of our to-go support materials is HIPS. HIPS is a classic breakaway. I remember when HIPS was introduced to the 3D printing market 6, 7, 8 years ago, it was like, yeah, HIPS can be a good alternative to ABS. It has the same properties. And yes, it has closely the same properties, but one of the real benefits is that the adhesion between HIPS and ABS is not very high. We use therefore HIPS for printing ABS-based materials, but also for ASA, PC ABS, and other PC compounds. HIPS has a good terminal resistivity. It can be printed up to 100-degree chamber temperature, and we print it with a zigzag pattern, which allows a very easy breakaway of the structure, because it can be just folded together and then the interface be peeled off. Important is we tested multiple different HIPS, and we found that not all work really good as a support material. Some have too high adhesion, some have too low adhesion. So if you ever want to try to print with HIPS, you should test ours first. Yeah. SP3030 is our next generation water-soluble support material, and it is the next generation because it has the faster dissolve rate, as you already saw in the video, but it's also the next generation because it has a broader range of compatible materials. Not only that it's compatible to the same materials as PVA, so PA6, PLA, TPU, but it's also combined for a material called ABS+, which is a special ABS in our portfolio to make it compatible with SP3030. So this is like a matching combination. The benefit of SP3030 is the good terminal resistivity. If you remember, I said with PVA, you can get really into trouble, different kind of issues you can get because of its thermal thermal sensitivity, and for SP3030 it's not the case. This is a big ABS plus part. It's printed on our FUNMAT PRO 410, and it's something like a 2-day sprint, and it just repeatedly go from bottom to top again and again. And in the end, also the real benefit is the faster dissolving time. Yeah, that for such a kind of part where you need multiple 100 grams of support, that you don't need to waste days of support removability. Actually, one material you already saw today is SP3050, our breakaway specifically developed for PA12 based materials such as PA12 carbon fiber, but also PA12 without reinforcements. Actually, this is one of my favorites. It's really easy to print. It really works with all parts. It has good thermal resistivity, and you can just go with it. So PA12 carbon fiber and SP3050 is a really, really good matching combination. We also printed with the zigzag pattern, and as you saw in the video, it's very easy to break away and to remove it from the part. Starting with our high performance support materials, we have SP5000, yeah, which is a hybrid support material. Hybrid means in this case it needs to be softened in a solvent called ethyl acetate. Some of you might know this solvent because it smells similar to nail cleaner. So even if you don't know the name, you might have smelled it already somewhere before in the past. The benefit is the SP5000 gets really soft once it was in the ethyl acetate for a couple of hours, and then it's very easy to remove and to break away. And actually, this is one of the reasons why we like SP5000, because within printing, it's very rigid, very stiff, and gives a very, very strong adhesion to the part to make sure the peak part stays in place and do not move and get layer shifting or warping in the part. It's working for all of our peak-based materials, but also for PPS, another high-performance material. It is thermally resistant up to 130 degrees, and this allows it to print all peak materials in amorphous state, whether on 410, but also on 610. As I say, in the printing process, it has a really good rigidity, which helps us to keep the printing process well controlled. The next support material is SP5040. It's a breakaway material exclusively developed for Pi 9085. So for Ultem, it has a good thermal resistivity. It can be printed at 180-degree chamber, yeah, which helps to get really good Ultem parts with high Z strength and no warping on the printer. And it can be also printed with zigzag patterns. So even on high and small structures, they are stable and stiff enough to keep the part well in position. And one of the main benefits of SP5040 is the easy removability after cooling. Yeah, because I know that some competitors, they offer also some support materials for Ultem 9085, but they need to be removed when it's hot. So as soon as your part cools down, you need to heat up the part, then you need to peel it, then your part cools down, you heat it up again. So it can be a really time-intensive process. And it's also not a comfortable process, because if you have a part at 150, 180 degrees Celsius, yeah, it's really, really more difficult to touch and not so convenient at all. The last support material in our portfolio is SP5080, also breakaway material exclusively developed for Ultem 1010 and also PPSU. This material is resistant to chamber temperature up to 220 degrees. So it really gives full printability on all of these materials. And there's all the other support materials, breakaways we print in a zigzag pattern to have a good removability. And also here, similar to SP5040, you can easily break it away once it was cooled down. And this is really, really a benefit, yeah, because at 220 degrees, it's even more difficult than at 180 degrees. And now you would say like, wow, so many support materials, what do we do? Yeah, so at the end, our goal is for every main material we have in our portfolio, we want to have at least one support material. In the perfect world, we would have solubles and breakaways, but at least we want to have one support material, because we believe support materials are really allowing the next generation of FDM parts and are really the requirement to make it, to give more industrialization to this process. And we have those different materials for the different build materials. And in the end, if you're asking yourself, like, how can I combine them in the end? I don't know, Tim, I will not remember after this webinar. Then it's easy to say, because we have our printing process guide here on the example of the FUNMAT PRO 410. And you will see, okay, I want to print PLA. Then I have the choice between PVA and SP3050. Okay, I want to print PCFR, I need to use HIPS. I want to print a PA12 carbon fiber, okay, I need to use SP3050, and so on and so on. This is the printing process guide is what we deliver to every printer, and not only tells you what materials compatible to which material, it also gives you some drying instruction. And important is, it doesn't mean there's no other support material combination possible, but it means this is the tested combination. This is where we have the profiles for. This is where you load your material. This is where you slice your parts. And this is where your part will be successful at the first trial, and no big experiments or headache while printing. In the end, it's all about support materials, and I believe support materials are the requirement for the next step in industrialization of FFF, to allow more parts in better quality of printing.
Thanks, T. Thank you for the very detailed introduction, and I think it was very interesting for us, all of us. So we still have around 10 minutes to answer your questions. Before I pick up the first question, just a reminder that you can still ask questions using that Q&A button. So feel free to ask any questions right now. If we cannot answer all the questions, we will definitely get back to you. And Tim already shows the 2 email addresses that you can send email to us afterwards to ask any questions. So let me have a look. Maybe we start with a most easy one. What does SP stand for in the name of the support materials?
Yeah, so how I think HIPS has anyone here before, and PVA has many people have here before of it, but not of SP. And SP means INTAMSYS own developed support materials. Yeah, those are materials you will not find in the open market. This is something that we develop out of the demand that we say, okay, we have a new material we want to add to our portfolio, and we need the support material to print it. And then we usually start with the development. So the SP series is full INTAMSYS development. Yeah, and what you also need to know, we have the SP3 range. Yeah, so 3030, 3050. Those are for the engineering plastics, and we have SP 5000, 5040, 5080. Those are for the high performance material series.
Perfect, thanks. I see other 2 questions. Actually, we can combine them together. So it's actually related to the high temperature support materials. So people know that INTAMSYS is specialized for high temperatures. So is there any soluble solution, soluble materials for high temperature materials possible? Or maybe we are working on it? And another question would be more related to the SP5000. Why we need SP5000 for peak specifically?
Yeah. So so let's first answer the question like water solubles or solubles. So first of all, in a perfect world we would have both, as I was saying already in the presentation. We are partnering with some companies. We are trying to make solubles that can resist 180, 200, 220 degree or even more. Yeah. But it's not so easy to develop, and we get somewhere to a point where more and more solvent is needed and less water-based materials. And it's not only about the thermal resistivity, because this is existing for some materials, but it's also the adhesion. Because in the end, we need a reliable printing process. We need to say, dear customer, this is the part you want to print, load your part and print it successfully. And we found so far, all what we tested and all what we have in our R&D center, it's not good enough to bring it as a solution to a customer. But still, we keep the pace and we try to find a good solution to have a soluble in the high temp for the high temp range. Yeah. And your question for SP5000 for peak, I think it's important to keep in mind for peak you really need rigid and strong support structures, because there can be a little bit stress in the part, and therefore we develop SP5000 because it's a very stiff and rigid support material. Yeah.
Thanks, Tim. Actually, another question related to that. Maybe I just pick it up this first. Is there any general support materials for high temperature materials? I guess he's expecting something that working for all the high temperature materials. Why we have so many different support materials for autumn, for peak, and so on.
Yeah, I think important is to consider in the end how are they working. So let's say we talk about a soluble. On the soluble, we have two requirements. One is our main material sticking on the soluble, and our soluble sticking on the main material. Yeah, so we need adhesion in both directions, and this is very difficult, and especially if it comes to different polymers. Different polymers have different capabilities, let's say, in sticking to another polymer. So they don't have, not all materials have the same adhesion to each other. Yeah, like some are bonding better, some are bonding less. And this is the reason why we do not see a chance to have one and all support material. And if it comes to a breakaway, this point becomes even more visible, because it really matters that we have a certain adhesion while printing to keep the part in place, to avoid warping and moving and falling off and whatever all can go wrong. But we still need to be able to remove it well afterwards. And sometimes it's really like, okay, you put a bit more of this additive inside, or you have two main materials inside, and you change the ratio between them. Yeah, I mean, it's difficult to say what we do in development, and I think that's understandable. But I can say all in one material that would be plug and play as we expect our solution to work at the customer side is not possible in the current stage of the market. Yeah, with all known knowledge, I would say.
Oh. Okay. Let me have a look at the next one. Are the support materials are all moisture sensitive? Any instructions to store it?
Yeah. So how I think you know me very well. I would,
yeah.
The first question is, have you dried the material? Whatever we do internally, it's always about, have you dried the material? And drying is really key. Yeah, because I would say if we say 80-degree 12 hours, then you should do 80-degree 12 hours, not 100-degree 6 hours, not 60-degree 24 hours. You need to stick to the time, you need to stick to the temperature to achieve the dry result that you want to have. And what we can say is if you look back to our, if we look back into our process guide, is that we have the drying conditions specified for all of our materials, and all of them are moisture sensitive, some less, some more, but all of them have some moisture sensitivity. So it's really important to keep materials dry and to dry them actively. And the second question of you was how to keep a material dry. I think the best way is actually the Intam box that we now started to deliver with the 310. We use in our workshop already a couple of them. And if we have a material combination that we don't use at the moment, we place it in the box. And once we need it, we dry it again. Then we print again with it. So even if you store it dry, redrying is required in most cases. It depends a little bit on the time, but for a material like Ultem, even in a dry condition, there is a risk, let's say, that it somewhere start to absorb moisture, because also the box cannot maintain a moisture for years. It's more for like days to weeks. Yeah.
Yeah. Thanks. Yeah, I think I still have one last question. I see here, actually, I'm also curious about it. Any more new support materials coming up in the near future?
Always support materials are coming. We see when we look into our portfolio, our own approach is definitely on the support material side, because we see this is where we bring real benefit with a new material. And I can say there will be something new coming. The when is more a question, but it's definitely there are definitely some things in the pipeline. It depends a little bit on how it goes with R&D, and then we release it into the extrusion process and so on. But we will release more materials and more support materials in the future. Yeah.
Yeah, I would say subscribe us in YouTube, LinkedIn, all the channels, and we will let you know when we have new materials. Yeah. Yeah, I think
if you have any questions or you want to discuss something in private or you have a longer topic, feel free, send us an email and we will get back to you after the webinar.
Cool, perfect. Thanks, Tim. I think we are perfect on time, and there are also no question more, but no worry. Please let us know if you have any question in your mind also later on. So get in touch with us and also contact our local team in US. I believe you have a contact details. So yeah, so thank you very much. Thank you for taking the time, and I hope you enjoyed it. Yeah, have a nice day.
Thank you, everyone.